Good morning, everybody. So, welcome to this session about extreme DevOps using Kubernetes. This is, of course, a sponsored talk by IBM, and we will be talking about, most of the time, the IBM distribution of Kubernetes. So, that's why you will see ICP. So, ICP, that stands for the strange name IBM Cloud Private. And this is our implementation of a private cloud, hosting a multitude of cloud types, including the Kubernetes environment. So we will be doing a dual session. So I'm going to do more of the talking about the positioning. What is this part of Kubernetes? How do we introduce that in DevOps? What can we do with integration into the pipeline? And then we go into a demonstration part, which will be led by Eric Catoir. And we will go through the tool sets and see the deployments. So first of all, what is IBM Private? And yes, I need to stand in front of the camera. IBM Cloud Private is a set of cloud types, and this is the Kubernetes part, Cloud Foundry part, but also we have a Cloud Automation Manager helping you with even old VM deployments in a cloud strategy. So we bundled everything together. We made sure that everything can be deployed with a single installer. We have Ansible automation scripts already made for you. You can deploy whatever you like, single cluster, a double cluster, federation, whatever you want. And we pre-integrated everything what is needed to do DevOps. Meaning we will have an LX stack, we will have Grafana, we will have Prometheus for the monitoring, so that whatever we do from a deployment point of view, you also are able to get the operational side, see what's happening, are there performance problems, are there issues, so that we can have a very fast feedback loop into that development cycle. So the whole bundling is done by us, pre-tested, delivered, and every 60 days we are going to deliver a new drop of the full platform, including some of the content. The third item that you see, it's all about content. The platform is as good as the content on that platform. So we will be publishing through a public GitHub our middleware, but there are also other repositories like the Google one, which you can just enter into the platform, you sync it up, and you all have a bunch of very nice open source tooling and middleware available in your catalog. And of course, we are also adding now the Cloud Foundry part so that you can create also another style of cloud services which you can interlink with the public cloud of IBM so that you can have access to the Watson APIs or the IoT APIs. So the deployment is a standard deployment. So we are not altering the distribution from open source. It's going to be completely as it is. We just are going to follow the releases very, very rapidly. So we added a boot node, and this is very specifically to make sure that we can do maintenance on the platform. It's very nice that it is there and we can do development and we can deploy stuff, but once we are in an operational phase, we need to do an upgrade of the platform. We need to add new components. Maybe we want to switch the plugin for the overlay networking. This is going to be done through that boot node. And we are also going to deliver a mechanism once you have things in production that you can do that while running the whole upgrade. So we have master nodes. There you can have multiple master nodes if you want to have a high availability part. You can have as many proxy nodes as you want. If you want to segregate proxy nodes because you have multiple divisions or whatever, we allow you to split them up. And then you have a bunch of worker nodes. Worker nodes, all the containers are going in there, and you can deploy all your very nice applications or through a push of the Docker images manually, or you can use Helm chart automation to orchestrate maybe a full set of containers at the same time. Now, we support multiple infrastructure types. So we have x86, where we have OpenStack, and where we have VMware as an infrastructure as a service part. By nature, this is what we support. We also have the IBM Power environment, which you also can have as a full implementation. And then we had a request, especially from the banks, can you also put this on a mainframe so I can do full encryption end-to-end into my worker nodes, and I can run then my container workload inside the mainframe. You can have all of these in the same implementation, meaning I have one cluster, multiple worker nodes with multiple or different technologies behind it. And then, of course, you need to make sure that you're going to do node selector tags, because you don't want to push an image which is bound for power to go to x86 or to Z-Linux. It will not happen. Make sure you have the tagging and that the Helm charts are using these tags. So besides the normal stuff that we have from Kubernetes, IBM is adding a lot of stuff. One of the things that we are adding is the cluster management. So we have also a specific, and we call it the Bluemix interface, where you can manage your clusters, where you can also go and have a very quick look at certain specifications, but we also help you in deploying very fast a Kubernetes cluster. So once you do a little bit of automation, you can deploy a full cluster with multiple nodes in under 40 minutes. And that's fully installed, everything prepared, integration for the monitoring, everything is in there. We will have the security in there, the isolation levels. Why did we do that? We removed the standard overlay network and we plugged in Calico. And with Calico, we can have network policies so that you can do segmentation for your development pipeline or for multiple divisions in your production. So you are able to design and create your own cluster and then automate that deployment so that it's immediately deployed for your liking. How are we going to deliver it? So every 60 days, we are going to do updates. Updates can be on the platform itself. For instance, in December, we are going to release a new drop, and there we are going to move from 1.7.3 Kubernetes to 1.8. So we will be pushing that as new code. So on the community edition, which is free of charge, which you all can use, it's just going to the Docker Hub, get the installer in there, download it, and then you can start downloading and installing your cluster. From a content perspective, we will be updating our GitHub with all the content, all the containers, everything which is there. You just need to push the sync button from now and then you will have everything into the catalog. So, as I said, it is a specific implementation from IBM on Kubernetes, but we leave Kubernetes completely open. Standard APIs, so if you like to use kubectl or Helm CLI, you can do that. We will not block that for any reason, especially for automation reasons, if you want to integrate that into a CI/CD or into an integrated pipeline. All our UIs which are built are anyway calls to the API. So we are not doing anything special on that specific part. So you choose, I can deploy it on a single image, or I will deploy a full cluster. It's just into a config file where you say, this is what I want, and then he will deploy that for you. Content will be delivered through a number of catalogs. You have the GitHub from IBM. Then you have the open source GitHubs, and the most popular one is the Google one that I saw. That's always pasted in. You sync it up and you have it. And then you can create your own catalog. There is an image catalog and a repository for your Helm charts so that you can create your own stuff, deploy it, test it, etc. So enterprise ready, we have to make sure that we can isolate, we can scan our containers. It's not only scanning the containers before they go into a repository, but also once we are running, I need to make sure that my stack stays secure and not vulnerable. So the scanning is also going to be implemented there. We have some access-based controls, but we also are doing auditing and eventing through the Alex stack. And then from an operations point of view, full integration with Helm, full integration with, for instance, Jenkins, so that you can start deploying your applications just by pushing code, picking it up, building the container, then creating the Helm chart, and then we push it out to the environment. And we will help you also from an operations point of view to really see what's happening, what are my events, is everything going okay, what is in the logging, etc. So this is the release. This is everything that you get with the new release. Here you see also the Cloud Foundry. You see the Kubernetes part, and we can bind everything together in one single catalog. So from a DevOps point of view, I will now describe a little bit how we integrate, what we do, and how we push this, and what IBM is also delivering as a tool to get an integrated DevOps pipeline. And there we also chose to use open technologies. Our belief today is that we need to respect the open technologies. Also, that's the reason why we kept the APIs open from Kubernetes. And here also for the deployment part, we will be using Helm. Helm is one of the most popular parts to get orchestration of containers or container applications. So we will be packaging, we will be creating the Helm charts. You will be able to push the Helm charts into your repository, and from there on you can start using them in a self-service. And later on, we will push that to operations so that they can also use the same Helm charts to deploy the applications to production. So, first of all, what you can do, and this is how everything started in the beginning, it is a manual push of your Dockers, your images. You deploy that, and then you need to go and create your services on your own, because once you have an image deployed in Kubernetes, by definition, it's not accessible. You need to get it as a service so that you have an ingress port and that you can reach it. So you have to do everything manually. Now, we automated further by using the Helm environment so that you can create the Helm charts. A Helm chart can create a full environment completely. And that's not only the Docker image with your application in it. We can orchestrate how secrets are deployed. We can orchestrate how persistent volumes are deployed. We can orchestrate how we need to interact, etc., and also exposing these services. So everything can be created as code. So a bunch of YAML files in a Helm chart, and that's what we are going to push automatically. Of course, once you start doing production, you need to certify, you need to make sure that these repositories are secured, and that in the end, we are going to be able to scan them, make sure that we are doing the proper versioning, etc. And then, once we go further, what we see, especially in the regulated environments, we need to segregate these environments so that we have a very defined environment for testing, QA, etc., and a separate environment for our production. We have the ability to federate them from a single management point of view so that we can orchestrate also the end-to-end deployment going from the code up to the production environment. And then, of course, scanning, as I said, not only the repositories, but also scanning everything which is inside and running. Because today I have a stack which is optimal, but maybe in 3 months' time we find a vulnerability. We need to scan that and flag, hey, we have a problem, so that we can start building the new stack, push it through, and then have a new deployment or a replacement. And then we can extend the whole thing. If you want to deploy then not only on-premise, but also use Kubernetes outside, for instance in AWS or in IBM Cloud, we can extend the whole thing so that we can deploy and make sure that we have this kind of flow between on and off-premise. So how do we do that? Natively with the product, we have microservice builder in there. It is a construct based on Jenkins. That's the pipeline. There we altered the Jenkins. We made a lot of processes in there so that once it is hooked up into Git, you just push the code. The Jenkins will then take your code, build the container, build the application, create the Helm chart, and then publish it automatically to your environment. Of course, you can build your own. You don't need to use this. For me, this is a very well and good example on how to integrate into existing environments. And then, of course, we have also a fabric, which is automatically picking up your deployments, and then all your logging, all your information can be sent to an Alex stack, and we are also using Zipkin if you want to do debugging on microservice applications. So this is the pipeline. Eric is going to go a little bit more deeper into that. And that's the microservice fabric where the Alex stack is for the logging, the events. And if your middleware or your application is able to send FFDCs or whatever to a Alex stack, we can pick that up immediately. You have one dashboard to look at so that you can investigate what's really going on if there are problems, and you can do your debugging from there on. That is the linking that we have if you are interested to see what we can do. And then now it's time for a demonstration.
Okay, so demonstration. First of all, I will explain a little bit what we're going to do, and then I will show the various kind of aspects. So how does it typically work? So the first thing you will have to do as a developer is build your microservices and then bring them together in an application. And we will see that the microservice fabric has a number of command line tools that can help you in doing that, and already defining a lot of things like the build files, the Helm charts, etc., that you will need later on. So of course you will still need to modify it afterwards, but it already gives you a head start, and you can also, you have the options we will show you. You have the choice between various technologies, so you can do that for Java with Spring, or for Java with the microservice profile, or you can do the Node.js route, etc. And we offer you also the possibility to modify those templates. So if you want those templates, they are just in GitHub, and you can start from there, and you can modify them and do your own thing based on whatever you want. Next step will then be, okay, you push this code into GitHub, and that will be your starting point. And then we will configure the microservices fabric to pick up the code from there. It will then be able to do the builds. Of course, we need to code whatever the business logic of our microservices, and that will immediately, the build will push it to the default. In this case, you can also again change it. It will push it to the default namespace in this Kubernetes cluster that we will use. So as a developer, you can just quickly, without any constraints, push your code and try it out on the cluster. Afterwards, we will combine with one tool which then is also had on the slides, which is our Urban Code Deploy tool, which will use basically exactly the same Helm charts, the same approach to push this, whatever the developer produced, to the other environment. So you can then also push it to a test where testers can then validate that everything is okay, and then finally push it through to the production, eventually with some approval gates, etc., to ensure that nobody just by accident pushes code into the production. So that's kind of the setup. Again, it's all customizable. In many cases, you will have more stages. That's all possible. It's just a question of configuring things. So let's now switch to the demo view. So, let me first show you a bit the cluster we're going to use. So that's maybe the good thing to start with. So this is typically what you get when you log on to this IBM Cloud Private user interface. So it gives you immediately a view, is my cluster in good shape? And it gives you a few metrics about memory consumption, overall CPU consumption. So you get the first view, are things in good shape? You also see how many nodes there are, and if we look, in fact, we can show you, this is a demo setup where we have one master node and two worker nodes, so it's quite simple, basic setup, but already with multiple worker nodes, so that you can do some failover at least. But again, this is completely configurable. As Dennis said, we can add worker nodes. You can do high availability setups with multiple master nodes and all those kind of things. But for the demo, we of course didn't need that. The other thing which Dennis was mentioning was this catalog, which is quite nice. So here you see all the Helm charts that are available in the repositories that you added. So if you add the Google repository, you will also start to see the Helm charts that are available there, where you can deploy lots of open source code. By default, it will be configured with a stack with a number of IBM capabilities. And our recommendation is also that you use the Helm chart approach to do your own deployment, and as such, you could also set up your own repository with Helm charts, which you then going to use to deploy. And if you do that, then your applications will also show up as these kind of icons. Just to give you an example, if I want to use for my, and we later gonna use that also in the application. I want to use a cloud and database for my development. What do I need to do? I can basically instantiate this. I get some explanations. Basically, I get the command that sits behind this chart, so it will just do a Helm install of this particular chart. We can click on this configure, and that would launch the Helm process. It allows me to fill out the various parameters. I'm not going to do it here. We will immediately see it being done through the microservice fabric as part of our application. The Helm chart parameters, you would, for example, need to specify persistent volumes where the database will go and all those kind of things. And that's also things which you could configure either through the user interface or just through the usage of kubectl commands, because it's just all Kubernetes kind of concepts. So that is the environment where our code is gonna run. Let's now start the journey, and we're gonna play the role of a developer. And let me. That's all, no, too many commands already. Okay, so I'm first going to log into this tool. That will give me the possibilities. So I'm logging into the IBM Cloud, and then I can basically create a new project. Create. And this is now going to ask me a number of questions. What do I want to really do? In this case, I want to build a microservice. You see, there is also possibilities to generate skeletons for a web application, for a mobile application, etc. So, and as already said, these patterns, they are just available for you. You can also add your own and modify as such what is happening here. So I take the microservice, it has only one option, and now you see if I select microservices, I have multiple technologies choices. I'm here now going to take the first one, the Java micro profile option from Eclipse, but as you can see, there is also possibilities to do a Node or a Python or a Spring Framework-based selection. And again, these templates are just coming out of a GitHub, so you can also do your own stuff there. Voilà. Oui. Okay. This option, as you can also generate them for usage in our IBM Cloud, and then you can also make use of, for example, Watson services, etc., and add them to your microservice project. I'm not going to do that for now. And this is now going to generate okay, that's already not so good for a demo. Wait, do I have... I will take the one which I already generated before. Okay, yeah, it doesn't contain any code. Okay, I'm not going to do this. I will show you an example through our GitHub repository. So normally it should generate you already all the pieces, in this case with the microservice profile, it generates a Maven file for your build, it generates a Jenkins file, it generates the Helm charts, etc. So I'm going to show you an example of such a project and of the code which we're going to use for the application. Okay. So I have here a number of these repositories which contain the code. So the microservice profile sample that we are using for this example is a kind of is a quite known microservice example. Which gives you an application for managing the sessions at the conference, where then you can manage the talks, the people, the speakers. You can also manage then the voting, so people can vote, etc. And this is in fact, the microservice which is being used for the vote. So a few things that I want to show. So and these are the things that are being generated by this command line tool. So first of all, it will generate a Jenkins file, which will then be used by the microservice fabric. It generates a Docker file, and let me open it. In this case, as it's so this Docker file will also change depending on the technology's choice. So in this case, it uses the Liberty microprofile as the base image to add then the code to. And of course, all these files are just the basis. You can yourself edit what you want. But this will allow you already to do, so there is the files necessary for doing the dependencies for the Maven. There is the Docker file, which allows you to generate the image. And then there is also this folder with the Helm charts. So it already generates basically also a basic Helm chart, which I can show you. So in this case, it's very simple, and it makes use of a number of the templates in the template directory. Of course, this is again just the basis. So if we look, it basically has the template where, for example, there is a deployment file, etc. So this is where we start from. This whole combination will generate the basic Helm charts to perform a deployment, and you will see, for example, it has already all variables in there to replace the name, etc. So these templates help you in keeping things consistent and generating the right code. Again, they come out of they are just publicly available in GitHub, so you can do your own stuff if you don't like them. And of course, in many projects, you will start to edit them. For example, here we have also added a Cloud deployment because this microservice is using a Cloud database. So if I look here, there is also a Helm chart in which will in fact deploy the Cloudant database based on a Cloudant Docker image. And here you can see the commands it does. There is some stuff in there to generate the secrets to access the database. There is also the volume mounts to mount the storage, etc. So all that is in there and comes out of this generator. So let's now, this application in fact has multiple of these services. So there is one for the voting, which we just seen. There is one where you manage the sessions. There is one microservice to manage the speakers, the schedule, and then there is also a web application, which is the user interface for this application. Now, what you need to notice is that we deployed, we put this all in one organization, and that will also be the basis for what we're going to do with this microservice builder fabric. So let's now switch to that fabric. Oops. I guess there is some network issue. And that's probably also why my command line failed. Okay, I'm back in. Workloads, deployments. So, in fact, this microservice builder fabric is also something which you can deploy through the Helm charts. So what it will do, it will basically deploy a Jenkins with some pre-configured content in it. And if we want to go there, I can just see, okay, this is the HTTP port where it was deployed. And here is my Jenkins. And what we see is that here, in fact, we specified that it needs to check all the projects within this IBM Simel Arrow organization. And if I click on it, we will see that it found in there those 5 projects. The one which we've already seen, the microservice builder vote piece, and then there is also all the others here that are being picked up and for which there is a build pipeline being generated. So if we look now, here is actually a build that we've been running, and I will show you a little bit. I'm not going to run it, but I will show you a bit what is happening in this build. Yeah. So first of all, it will basically first do the regular Maven build. So you see that it did a lot of picking up of all the dependencies, etc., and which are needed, which came out of the POM file. Yep. Still. Okay, so once it did that, then in fact it's basically doing the Docker build based on the Docker file that was also part of the project, also the generated file. So it's basically doing the Docker build, and as a result, I have an image that's being created. And then the next step is it will do some validation whether this deployment will successfully happen. So what it's doing for that is it actually creates a temporary namespace in the Kubernetes where it will deploy. So it does a Docker push to put the image, and then it will basically deploy the microservice and then it can execute some test code, etc. And if all those tests succeed, then it will again use the Helm chart to do the same deployment into the default namespace. So that is basically what this microservice builder factory is doing. And so at the end, you see it has deployed the microservice vote, and it was not yet available here in this case, and it did also do it, and that's the thing which Dennis was mentioning. The Helm chart will also do things like expose the service and all those kind of things. So if we, so that's basically what the microservice builder does, and it can do that for all the projects. So if you now add a new microservice into that same GitHub organization, it will pick that up, and it will also automatically, each time you check in new code, it will launch the builds and it will deploy them into the cluster. One of the nice things with that setup is what we see more and more happening is that instead of companies making just one DevOps setup for the whole organization, is that it becomes now very easy to set up your own pipelines for every department, which you can then tweak. You can add whatever tools you really like, and that gets you out of those discussions where people say, no, we don't want to use your pipeline because we need this other tool, or we don't like the tool you are putting there, etc. So it gives you the possibility to do some standardization, but still give the people some freedom, and that's the nice thing about it. Now, let's look what these deployments then have done. So as a result of the, if I switch off this filter and I add so in fact, as you can see now, there is here these deployments, and the fact that they have been done through Helm chart is that's why they appear up here. So we have, if I go back to this vote service, I can see that there is a pod running here with this kind of service, and we can see, for example, log files, etc. So I can just see that the thing has been deployed and is up and running. And now I can test the application, and just to show, it's also you can just use the kubectl commands towards the cluster. So, for example, if I want to know okay, so I definitely got the network issue here. Let me reset my kubectl context. Voilà. So this is just an example of accessing the same cluster using kubectl. I now see that these microservices have been exposed through ingresses, and that also my web application has been exposed. And if I now take this one, so the application is running, and I can see here the speakers, and I can click on it. I can look at the various sessions, and then I can add some votes. and then see the result of those votes, which are all being stored in the cloud and database, which was deployed through the Helm chart, etc. So this is kind of the journey which the developer would see. So he would do this command line generation of the skeleton, then check that into GitHub and work with a team on the code, etc. Then once the code is already set up, the microservice builder pipeline, and that allows you to deploy this application. Again, now it's deploying it in the default namespace. You could make options. You could create a dev namespace or whatever to do so. And as such, have your cycle. And as this is just all based on the open source, you can do anything you can do normally in Jenkins. You can add whatever code validations and all those kind of things you want. So let's now have a quick look still at the rest of the journey, which was in the slide. So now I've been doing this development. I'm happy about this. So how am I gonna push this into other environments? And therefore, I have here this tool called Urban Code Deploy. And this will help me. What is the advantage is what I've been doing now. I've just pushed the images, and I have no really trace what version is there in that namespace, etc. With the Urban Code Deploy, we will be able to define an application. So in this case, we have been defining this application with the name microprofile. And then I've defined multiple environments. So I have, for example, a test and a production environment. It has not yet been deployed on the production environment. It has been pushed already to the test environment. And I can here, it also keeps track of all the version numbers, etc. So I can do rollbacks and all those kind of things. If we look what sits behind that, so if I click on this microservice profile for the vote service again, I can see that what it did is a number of steps to deploy the Helm charts, etc. So it's basing itself exactly on the same Helm charts that you have been putting into the repository. And that's important because in that way we know that because it was working in the dev environment, that it also will be working in the other environment. If we look in this urban code, we can see what is the process sitting behind it. So, and that will show you that it's yeah, this is a bit of an eye chart, but luckily we can zoom in. So what will it do? It will first create a working directory. It will download the artifacts out of the GitHub repository. So it will download the Helm charts out of the GitHub repository. It will do some substitutions because, of course, now we might need to go to a different cloud and database, etc., for the other environment. So it's going to do that. And then it will basically, there is a step here. Yeah, so it's creating the environment, setting the context, and then it does the Helm initialization, and then it will check whether the application already exists, because then you have to do a Helm update, or if the application is not yet there, it will do a Helm install. So that's the process that sits behind. Just to show you, it's doing nothing special. It's just using the same Helm chart to perform the deployment to other environments. And this allows us to deploy the same application to the to our own cluster, but maybe in a different namespace. So you could create separate namespaces for test, production, etc., and as such keep the environments neatly separated. But it would also allow you to use the same Helm chart to deploy to our Bluemix cloud, where you have a Kubernetes environment, or to any other Kubernetes environment that is available for that matter. So, and that is more or less what I wanted to show. No, wait, we can still see, Dennis mentioned that there is also the logging information. So, as said, the environment contains also capabilities to keep centralized log information of all the applications. So we can access this up. And again, this is just an Elk stack, which is also deployed within the cluster as part of the So as part of the deployment, there is this Elk stack, and it will log all the information of your containers through just some file loggers. So anything that goes to standard out, standard error, etc., can pop up in these kind of log files. But also, if your application uses the log stash, you can just push your log information, and then you have all the capabilities that you have in Kibana. You can create your own dashboards, you can do whatever you want, and then you can search in it, have graphs, etc., and keep a centralized view on all what is happening in your applications. So that is basically the demonstration we wanted to show you. We are also available. We have an IBM booth here, so if you want more information about this Kubernetes implementation on whatever kind of aspects, we are there. So if you want, you can still come there for questions. If there is questions here, there is just a few minutes left, so I don't know if anybody has a question on this. No? Okay, then I thank you for your attention and maybe see you on the booth.